So one of the last things we're going to talk about in this lesson is how does the size of the sample that we took to get our sample mean, to get our point estimate, how does that affect our confidence interval? So as the level of confidence increases, the confidence interval will widen. The more confident you are, the bigger your confidence interval. But if your confidence interval is very, very, very large, say an interval like this, compared to a confidence interval like that, which one do you think is more precise? The one on the top is more precise because there's only a smaller amount of values that I could pick from. For instance, it doesn't really tell you much if I tell you that the average age of a student at RCC is between 12 and 45. That's a really big gap. But it does tell you a little bit more if I tell you the average age of a student at RCC is between 18 and 23. That gives us a little bit more information. This is more precise. So as you increase your level of confidence, which is something that people would want to do because you do want to be very confident in your answer, your confidence interval is getting bigger. But if your confidence interval is getting bigger, then your precision of your confidence interval is decreasing, which is not necessarily a good thing. So it's kind of like you have this trade-off, more confident but less precise. However, one way that you can improve the precision of your confidence interval without having to sacrifice your level of confidence is to increase the sample size. The more people you include in your sample, the smaller your confidence interval will be, the more precise your confidence interval it would be. So then that begs the question, just how large does the sample size need to be in order to get a certain level of confidence? Well, the answer to that question is your sample size should be equal to your critical value Z sub C multiplied by your population standard deviation divided by your error all squared. And if that sample size does not come out to be a whole number, then you will round it up to the nearest whole number. Now, if you do not know sigma, you can use the sample standard deviation to estimate it if your sample is at least 30 members. So this second bullet point does not apply to lesson 18. It applies more to lesson 19 because lesson 19 is going to be the lesson where we are finding confidence intervals and we do not know the population standard deviation. We only know the sample standard deviation. Standard deviation. Okay, so let's look at example 7. The researcher in example 1 wants to estimate the same thing, the number of hours that are spent on these athletic activities. His question is, how many student athletes must be included in the sample? So we are looking for N. N is what we want. We want to know his sample size. If he wants to be 95% confident, and he wants that the sample mean is within 0.5 hours of the population mean. If it's going to be within 0.5 hours, that is our error. So we're looking for N, and you don't have to write that question mark. I'll fill in the formula for N in a second. But if we're 95% confident, then our critical value, we've seen it in our standard normal table before, is 1.96. That is the Z-score that corresponds to a 95% level of confidence. And they've told us that we want to be within 0.5 hours. That is our error. You may remember from example 1 that the population standard deviation was given as 2.3, but we didn't pick that up until example 2. In example 2, they told us that sigma was 2.3. So now let's actually find what N is. I'm using this same formula from above. We're going to take the critical value, multiply it by the population standard deviation, divide it by the error, and square it. So we're taking 1.96, we're multiplying that by 2.3, we're dividing it by 0.5, and we're squaring all of that to give us approximately 81.29. Now, 81.29 is not a whole number, so I'm going to round that up to 82. So now I'm going to say the researcher needs at least 82 students, or rather he needs at least 82 student athletes in order to be 95% confident that his sample mean is within that 0.5 hours. And then the last example in here, you'll be doing the same thing. Pay attention to what your new error is in that last try it.